and this is the Mechanics Homework Booklet, question 28. So we've got a horizontal force of 1.5 kilonewtons acting on a motor car, 850 kilograms, that's initially at rest. Calculate the acceleration of the car. So that's a straightforward F equals ma. The acceleration is force over mass, 50. I end up with that value. Now, I'm writing down 1.8. That's the answer to two significant figures. I kept the full value in my calculator. Speed of the motor car after 15 seconds. It's a SUVAT situation. I know U, I want to know V, I know A, I know T. V equals U plus AT. Naught for U gets me up to that 26 meters per second. Again, I kept the full value, which is more than that indeed, in the calculator. Distance travelled by the car in the first 7.5 seconds. Again, I know S, sorry, I want to know S, I know U, I know T, I know A, so I'm going to use S equals UT plus a half AT squared. Use 0, which gives me S equals a half AT squared and gets me to that value, 50 meters. And then finally, I've got two options for doing it at 15 seconds. I could do exactly the same I did for part 3, but put in T as 15 instead of T equals 7.5. But because I've got this AT squared, I can simply look at it and say, right, I'm doubling T, I'm doing T squared, so if I double T, I end up with 4 times the distance. It is, in fact, 200 meters that I travel in those first 15 seconds. Moving on, we've got a diagram showing the force against time together with another 3 incomplete sets of axes. Sketch on these axes the corresponding graphs for acceleration, speed and distance for those first 15 seconds. So the acceleration, I've got the value, picked some scales that allow me to show that. The acceleration must be constant, no air resistance, no friction. So the force is the net force, F equals ma, constant force, constant acceleration, that flat line. If the acceleration is constant, that means that the speed against time graph must have a constant gradient. In other words, it must be a straight line. I know it starts off at 0 velocity. I know that after 15 seconds it's 26. It must be a straight line through the origin because the gradient is constant, because the acceleration is constant, and therefore I've got a line doing exactly that, going through those points we knew. Finally, trickier one is the distance. Now we know that the gradient of the distance time graph is the gives me the speed. With the speed constantly increasing, that tells me straight away that the gradient of the distance time graph must be increasing, so it has to be an upward curve. We worked out 2 times at 15 seconds 200 meters, and at 7.5 seconds 50 meters. We also knew, of course, that at the start there was no distance travelled, so I've got those 3 points. I know I've got to have an upward curve. It's got to look like that. The other way I could think about the shape is the fact that the distance is the area under the graph, and because of this upward slope, as I move along the time, the extra distance I add for an extra little bit of time gets bigger, and therefore that again has to curve upwards. The final mark was for completing the axes. Although you were given the quantities that were on each axis, you weren't given the units, so you did need to get those 3 units for that fourth mark. Moving on to part C. In practice, the resultant force exerted on the motor car will not be constant, as suggested by the force time graph. Air resistance is one factor that affects the resultant force on the vehicle. Suggest how the force time graph will change when air resistance is taken into account, and explain your answer. You may wish to sketch a graph to illustrate this. I didn't. With these suggest and explain, I often find it easier to explain than suggest, and that's what my colouring here is. Suggest what's going to happen there in the explanation. So the explanation would be that the net force is going to be the driving force, which may be constant, take away the air resistance. The air resistance increases with speed. That's a bit of knowledge you're meant to have, and which you always need to state in these type of situations, which is essentially talking about a terminal velocity situation. So the air resistance increasing with speed. If that value number that we're taking off, the air resistance is increasing with time, that's constant. Therefore, the net force decreases with time. And then again, explain why the vehicle will eventually reach a maximum speed even though the motorist keeps the accelerator pedal fully depressed. So again, they're implying that the force stays constant. Now, if that was a standalone question, I would want to be saying that the net force is the driving force, take away the air resistance, and the air resistance increases with speed. I've put those in brackets. They weren't on the mark scheme because you said them. They were said in the part above. Eventually, of course, what's going to happen is we're going to get to the point where the air resistance is equal to the driving force, and at that point the net force, if the air resistance and the driving force are equal, at that point the net force will be zero, and so the acceleration will be zero. So that's the explanation specific to this part here. So that was the mechanics homework booklet, question 28.